Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to solve some problems on AC voltage controllers and cycloconverters. So here in this we have total 10 questions. First 5 questions for AC voltage controller and the next 6 to 10 questions are from cycloconverters. So in the first question, AC voltage controller uses a triac. Triac means this is the triac symbol. So now MT1, MT2 and gate bidirectional device, and for phase control, phase angle control of resistive load of 100 ohms. So calculate the value of delay angle for having an RMS load voltage of 220 volts, and also calculate the RMS value of triac current. Assume the RMS supply voltage to be 230 volts. Solution for this one, first one. So now here first one, V0 RMS equals Vm by 1 by 2, Vm under root 1 by 2 pi minus alpha sine 2 alpha by 2. So now here this is the supply voltage. This is the supply RMS voltage, this one, and this is the supply voltage RMS value. Supply voltage, this one 230 volts. Supply voltage RMS value. This is the output voltage RMS value, and this is the alpha. So from this equation, if you solve this, if you use any iterative method, so that value alpha equals to 45 degrees. So now here, so next case, calculate the RMS value of triac current. So triac, this is the output voltage firing angle, and output voltage of this RMS value of triac angle. So here source current equals to output current. So now here this output RMS value is 220 volts. 220 volts divided by this resistance is known as the output current. So this output current is known as the source current, that is RMS value of triac current. This one, this is 2.2, that is the 2.2 amperes here. Now next case, AC voltage controller uses on-off control for heating a resistive load of 4 ohms, and the input voltage is 2208 volts 60 Hz. The desired output voltage is 3 kilowatt. Determine the duty cycle, input power factor, and sketch the waveforms for duty cycle obtained in the question number A. So now here the solution for this one. So same thing, same formula here in this. You need to remember only thing, V0 RMS equals to Vm under root 1 by 2 pi minus alpha sine 2 alpha by 2. So now here alpha equals to, you need to calculate this alpha value, and V0 RMS supply voltage is 208. And next thing here, power. So power, from the power you need to calculate the V0 RMS. How you will calculate? So now power equals to this power, output power equals V0 RMS square by R. R value is 4. So from this you can calculate this V0 RMS. This is 3000 by 4. So now here P0 RMS square, from this here V0 RMS equals to this one equals to 109.5. This is 109.5 and this one is 20.8 root 2. This is supply voltage. So from this you can determine the alpha value, delta, that is duty cycle alpha value. So not alpha value here, determine the alpha value. And next, input power factor. Input power factor equals to V0 RMS divided by, and supply voltage into R. This is I0 RMS squared into R divided by Vs into RMS by I0. That equals to V0 RMS by supply voltage. This is the RMS divided by 208 supply voltage. That value equals to cos phi equals input power factor equals to 0.52. And next case here, third question, A single phase load resistance 12 ohms is fed from 230 volts RMS and supply voltage 50 Hz supply by pair of inverse parallel thyristors. So this is the one thyristor and this one is one thyristor. So this connection, and it is connected to the AC supply and there is a load. For a firing angle 0, 60 and 135, calculate the mean power. First calculate the average RMS power voltage. So here calculate the RMS voltage output. So in that alpha value is given and Vm is given 230 volts. So now first calculate for 0. So 230 root 2 alpha equals to 0. 0. For this case, this value is same 230 volts. And next thing here, if for that case, if you substitute 230 volts and R value 12 ohms and that value equals to 44083 watts. So 4.4 kilowatts. And next alpha equals to 60 and same supply voltage and that alpha equals to 60 and this one and that RMS voltage is output RMS voltage is 192.8 and this power equals to same V0 RMS square divided by 12 load resistance and that power equals to 3097.6 that this is 3.097 kilowatts. And after that next 135 degrees angle. So same thing for that case if you substitute 135 degrees for that case 175.4 is V0 RMS and this is V0 RMS that power output power equals to 2563.7. So this is the 2.6. So now 2.567 kilowatts. And next thing here, a single phase full wave AC voltage controller feeds a load of 20 ohms with an input voltage of 230 volts 50 Hz. Firing angle for both thyristors 45 degrees and determine RMS value of output voltage V0 RMS and load power P0 RMS and input power factor average and RMS value of thyristor. So now here this one is also important. Same formula here V0 RMS equals Vm 1 by 2 pi minus alpha and sine 2 alpha, this is under root. And now here alpha value is given 45 degrees and this voltage is 230 root 2 and this R value is 20. Same thing here, this is 5 by 4 alpha and this is the supply voltage 230 root 2 and next here this value equals to 202.7. This is the RMS output voltage, this one. So from this you can determine the output power. So V0 RMS square divided by R. So that equals to 202.7 square by 20. And next here P0 equals to 2054. So now here 2.54 kilowatts. This is in the watts. So now from this you can determine the input power factor. Input power factor equals to I0 square R divided by Vs square into I0. So I0 gets cancelled. I0 into RMS, that is V0 RMS and Vs. V0 RMS is here 202.7 and supply voltage is 230. So this input power factor equals to 0.88. Next case, fifth one. A single phase voltage controller is employed for controlling the power flow from 230 volts 50 Hz source into a load circuit consists of 3 ohms and 3 ohms for resistor and this is the inductive reactance XL equals to 4 ohms. And next calculate the range of firing angle range, maximum value of RMS load current and maximum power and power factor, the maximum value of average and RMS thyristor currents. So now here solution for this one. So this is the phi angle formula. Phi equals tan inverse omega L by R. So now here if you substitute, this is the omega L and this is the R. And next here this value equals to 53.13. From this you can determine the firing angle range. So that firing angle range is always phi to 180, that is alpha phi to alpha 2 and 180 degrees. This is. So now here this phi value equals 53.13. The maximum value of load current means here 230 by this impedance Z. Supply voltage divided by this impedance. Impedance means Z equals to R plus J X L or R plus J omega L. And next here if you take the magnitude, that value equals to R square plus omega square L square. So under root. So now this is the formula. So from this R value and omega L value substitute it, 3 square plus 4 square under root, that is Z, and that value equals to 46 amperes. And next case here, maximum power and maximum power output already we discussed here. So 46 square into 3, and next that one I square R. So and maximum power equals to 63.6348 watts, that 66.348 kilowatts. And next thing here, so input power factor equals to I naught square into R divided by Vs square into R. So this value equals to I naught square into R means here I naught gets cancelled. I naught into R means V naught RMS. This one divided by Vs. So now here this value equals to, so I naught into R by 230. So supply voltage. So that value equals to cos phi equals to 0.6. And next case here, so maximum value of average value of thyristor value formula root 2 into Vm by pi Z. Z equals to here this value equals to phi. And now if you substitute here this one root 2 230 volt supply, and this is a Z and this is pi. Z equals to square root of R square plus omega L whole square. And next this value equals to 20.707. After that this IT RMS equals root 2 into Vm by 2Z. So this is just pi and 2. This is for RMS and this is for average. And now this simplification value is 32.527. Next case here. In a standard single phase bridge type cycloconverter, input voltage of 230 volts, 50 Hz, and R value is 10. And one frequency is 1/3 of input frequency. Firing angle delay is 30. And calculate the RMS value of output voltage, RMS current of each converter, and RMS current of each thyristor, and input power factor. Solution for this and given data. So this is the formula for average output voltage, RMS. And next here if you substitute, this is 230, this is the RMS value, this is the maximum value, this is RMS value, 230 into root 2, alpha equals to that this is 6, sorry, pi by 6. And next here calculate the RMS value of output voltage. So this value equals to 222.6, and after that this current equals to 22.6. And next thing here, that each thyristor current equals to this I naught divided by root 2, that value equals to 22.6 by rho under root 2. Next, input power factor equals to this I naught square into R divided by Vs into I naught, and this V naught RMS square. This means I naught gets cancelled. I naught into R means V naught RMS, and input power factor equals to 22. This voltage divided by 230 volts. This value equals to 0.98. Next, a 3-phase single-phase cycloconverter employs a 6-pulse bridge circuit. A device is fed from 400 volts 50 Hz supply through a delta star transformer whose per phase turns ratio is 3:1, And for an output frequency of 2 Hz, the load reactance is omega L equals to 3 and load resistance is 4 and commutation overlap and turn off circuit limit is firing angle in the version in inversion mode is 165. Calculate the peak value of RMS output voltage and RMS output current and output power. Solution for this, and this is the formula. So this peak value of RMS output voltage equals to, this is R and 200 and root 3 pi m by pi and pi by m. Here is m is number of pulses and here this R equals to cos 15 means here 180 minus 165 and this is this supply voltage is 200 and 200 maximum value is 200 into root 3, sorry. And next here if you simplify this, V naught RMS equals 319. And next from this you can determine the I naught RMS. So from divided by Z indicates Z value equals to 319 divided by this R square plus this omega L and R square plus omega L square, this value equals to 63.8 amperes. And next P naught RMS square equals to V naught RMS square divided by R. So that value equals to, this value equals to 319 by 4, that value equals to 20.35 kilowatts. After that, next 8th problem, a single phase to single phase, not midpoint, a bridge type cycloconverter is delivering power to the resistive load. The supply transformer has turns ratio 1:1:1 and supply frequency turns ratio is F naught. Output frequency by supply frequency is 1/5 and the firing angle delay of alpha for all 4 circuits are same. Shown the time variation for the 0 and 30 degrees. So for this is the case. So this is the supply voltage. First I will draw supply voltage 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the supply voltage. Let me change the color over here. So 1, 2, 3, 4 and 5. 1, 2, 3, sorry. 4, 5. So now here in this case, first 1, 2, 3, 4, 5. After that 1, 2, 3, 4. 1, 2, 3, 4, 5. This one up to here. And next this is for 0. And after that, next for 30 degrees case, it starts from here and next here, and this is 60. Next here, 30 degrees. Next it starts like this. So now this is the time variation of the waveform. And next thing here, a single phase to phase, 3-phase to single phase cycloconverter implies 6 pulse bridge circuit. A device is fed from 400 volts 50 Hz supply through a delta to star transformer whose for turns ratio is 3.1. And next for output frequency of 2 Hz and the load voltage is omega naught L is 3 ohms and the resistance is 4 ohms and the commutation overlap and thyristor turn off time limit the firing angle in the inversion mode of 135. So now here R equals to cos of 180 minus 135 and calculate the peak value of RMS output voltage and RMS output current and output power. Same as that 7th question. Same formula, R equals to this one, cos of 180 minus 135 and 230 root 2. Next thing here, m by pi sine m by pi. So now here, not this is 230, 400. So now Now this is 45, 230 by root, sorry, not 400 by 2. Now 6 by 6 pulses and 6 by pi and 5 by 6. So that V naught RMS value equals to 233. So now here this is V naught RMS and this I naught RMS equals to V naught RMS divided by Z. Z equals to R and this is the omega L. This is R and this is the omega L. So from this V naught RMS equals to I naught RMS is equals to 4.66. From this you can determine the output power. Output power equals to V naught RMS divided by R square divided by R. That value equals to 233 by 4 equals to 13.57. Next, 10th question. A single phase to single phase midpoint cycloconverter is delivering power to the load. The supply transformer has turns ratio of 1:1:1. The frequency ratio is 1 by 5 F naught by Fs. The firing angle delay alpha all for all 4 SCRs are same. Show that the variation of the following waveform 45 degrees and 60 degrees. The supply voltage and supply current. So now here output voltage and output current. So now same as 1, 2, 3, 4, 5, 6. So now this is. So now here it starts from here. One, 2, 3, 4, 5. Next 5 cycles. Next 5 cycles. If it is starts from 45 degrees, 45 degrees, 40. So 45 degrees, add 45 degrees. So now the diagram should be like this. If it is 60 degrees, so move again 15 degrees. So like this the waveforms will come. If it is a resistive load means same supply voltage and supply currents are same. I hope all these problems are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.